It's the first time we ever met, although I've been following you on the social networks for quite some time.
Yeah.
So again, I'm not qualified to introduce you, so I'm curious myself, and yeah, it's yours.
Okay, so first of all, thank you very much for having me here. As I told Jan already when he invited me, my talk, let's say, is not, from my point of view, not really fitting to the whole plan, but we'll get to that a little bit later. I'll be talking about, let's say, our design agenda. ALTU is like a group consisting of myself and Alexander Kalachov. We're doing, let's say, some sort of architectural research through workshops and also through teaching positions. He is teaching at the Dessau Institute of Architecture for several years now, and I recently also have a teaching position at the Cologne Technical University. And I will start my presentation with some images. Maybe some of you know them already. They're images of a group called Sigma 1 from Romania, Timișoara. It's a group of artists, and their work has been developed during the late 60s and up to the 80s. And I wanted to show this because I believe that the content of their work is still extremely interesting and extremely, let's say, still present, kind of this topic. They were trying to analyze like natural structures, and they were trying to depict geometries in different ways, like this kind of component-based systems. And also the whole idea behind it, where they were using this kind of workshops to kind of give their knowledge or share their knowledge together with a group. And also something interesting about them is that they were looking at creation as a process of groups. So they are not looking at their own work, let's say, as being an individual result, even if it's, let's say, signed by someone, but you always make use of things which already happened before you. So basically, in some sort of terms, your work is a development of something else. And next, I will show you a short video.
What is your definition of design, Monsieur Eames?
One could describe design as a plan for arranging elements to accomplish a particular purpose.
Is design an expression of art?
I would rather say it's an expression of purpose. It may, if it is good enough, later be judged as art.
Is design a craft for industrial purposes?
No, but design may be a solution to some industrial problems.
What are the boundaries of design?
What are the boundaries of problems?
Is design a discipline that concerns itself with only one part of the environment?
No.
Is it a method of general expression?
No, it is a method of action.
Is design a creation of an individual?
No, because to be realistic, one must always recognize the influence of those that have gone before.
Is design a creation of a group?
Very often.
Does the creation of design admit constraint?
Design depends largely on constraints.
What constraint?
The sum of all constraints. Here is one of the few effective keys to the design problem: the ability of the designer to recognize as many of the constraints as possible, his willingness and enthusiasm for working within these constraints. The constraints of price, of size, of strength, of balance, of surface, of time, and so forth. Each problem has its own peculiar list.
Does design obey laws?
Aren't constraints enough?
So I think this last question kind of sums it all up, and I believe that it's interesting that, okay. yeah, that it's interesting that, let's say, different people from different areas of the world at that time were kind of thinking the same, and I think it's kind of happening all the time. So the first chapter, let's say, of my presentation will be about material consciousness, so basically working with material and working with capabilities which the material offers you. And these are some works done at the DIA Institute, so Dessau Institute of Architecture, as part of the CAD-Logic course done by students. And of course, our, let's say, goal is to use flat sheet materials and to transform that flat sheet element into a three-dimensional component, which then can be replicated in a certain way in order to generate three-dimensional structures. And we try to do that by using the, let's say, opportunities which the material we choose has. So, for example, in this case, as we know, maybe plywood plus water equals the capability of bending. So a material which is usually stiff or can break once you change the environment in which it exists, it can act differently. And then the components which get generated offer I will not say a limitless amount of possibilities of connecting them with each other, but they have a certain degree of, let's say, emergent qualities, or the structure which gets created. And also using some sort of growth algorithms based on self-similar components. So same size in this case. The only thing which varies is the pattern of the shape, of the interior shape. And we also like to embrace, let's say, this kind of mistakes. So this hairy structure just appeared because we decided not to cut away the extra materials. And also from the same kind of, based on the same kind of principle, you have a square sheet which you bend, and then the stiffness which you get through the way you are bending the material allows you to generate a structure which is stiff or has certain qualities. And the last one, the fizz, it's also made out of this plastic material, transparent, and basically the structure represents some sort of an artistic installation, basically. And it plays a lot with the way the light behaves when it penetrates transparent reflective materials. So as soon as you have a conglomerate of elements, it becomes a solid, similar like in the image on the left. But every single element is transparent in itself. And using the same cutting pattern, but different connectivity, a different connectivity pattern, you generate families of components which can coexist in the same system. And now another short video.
There are many times when invisible connections link things together. When the variation of one thing determines the variation of another, then that connection is called a function. The size of the balloon is determined by the amount of air. The more air, the larger the balloon. The size, then, is a function of the amount of air. The height of a candle is such a direct function of time that the ancients measured the hours in this way. In 1 hour, the candle is 1 unit shorter. In 2 hours, 2 units. In 3 hours, 3, and so forth. The candle gets shorter with time. The boy gets taller with time.
This height is a function of time because it has a definite value at any instant. Your proper weight is a function of your height, and the number to which the needle points is a function of your weight. Your weight is a function of gravity. The less gravity, as on the moon, the less weight. The speed of the locomotive is a function of the heat in the firebox, the position of the throttle, the diameter of the wheels, the grade of the track, and the direction and the velocity of the wind. It is not likely to depend on the beauty of the scenery or the color of the engineer's hair. Many laws of nature are statements of functional relationships. Functions are the beginning, and sometimes they are the goal of science.
This was another video by Charles Eames, which was done for IBM, and of course it's showcasing or trying to explain the idea behind functions. And the second part of my presentation deals with the idea of emergent design, but not in the sense of emergent systems, but rather as emergent time-based functions. So, for example, in this case, it's a workshop we did in Qingdao a couple of years ago. We were also looking at how bending flat sheets of PETG can result in very stiff components. And we had different teams looking at different types of connections, and also looking at combining the properties of the plastic, for example, with metallic rods like they were using here, in order to create some sort of tension and to stabilize the components, or in this case using weaving techniques which they are very accustomed with in order to generate cells, and also to look at the way the cells could connect, and yeah, then look at the quality of, let's say, this surface or this volume which gets generated basically by these components. And we did then a second one as well on a similar topic, but also just looking at components and not at structures. So we did like weight tests on the results we had, looking at yeah, connections, some not so good and maybe some better. We used that, the knowledge we gathered at that point in time, we used it at our further experiments. But I'll go one step back in time, which is the first workshop we did also together with Andrei, who is here in Bucharest. And it was a workshop where a lot of people participated, and it was a lot about doing, so working with models and translating them into digital models. And then we had to choose, of course, from this process several structures which we wanted to implement at the one-to-one scale. Three structures basically emerged. One which was like a parasitic structure based on a component which was similar, so a lot of different, a lot of numbers of the same component, and the structure was emergent in the sense of the way it was occupying the space. The so-called wishbone, which was also like an artistic installation basically, or in this case some sort of a lamp, and the hexaglue. Back in those days, we didn't use any kind of algorithm to predict what's going to happen when we're going to actually build this structure. So it was interesting to see that that and how actually the structure changed over time. was made out of cardboard, and it also survived the week on the street when it was pouring. So somehow we're quite lucky with that. And then, yeah, it was very, let's say, well seen, especially by the kids who had a lot of fun playing with it. But actually, where I want to get is the workshop we did, the last workshop we did, which was in Poland, in Łódź, where we had plywood, 1.5 centimeter thick plywood, which we used in order to generate, or not to generate, to build this structure. And the process of the workshop was also similar, like the ones we did before. So we have like a week of tutorials and also design phase within this week. And we try to get to the point where we build a structure. And as I showed in the example of the Qingdao workshop, sometimes it's working and sometimes it's not really working. Sometimes we don't get to the point where we can say, okay, we can build a structure out of it, but we gather some sort of intelligence out of it. And in this case, it's a structure which gets generated around some cells, and with the use of kangaroo, it gets inflated, and then in order to lower the weight of the structure, we added the penetration of the penetration of these panels. And the idea behind the construction of this structure was to not use anything else but the material we had at hand, so plywood. So no other gluing elements or and these are like initial studies of different elements, and some people were just trying to figure out how to best connect these wooden elements. Some people were looking at surfaces, and I had the pleasure to also do extreme intense structure tests, which of course resulted in breaking the piece. But they were also, let's say, good enough at that point, and given the time frame we had, to say that this thing is going to work. Yeah, and here a little bit about the, let's say, design phase. So you have these 3 cells which are generated with Voronoi, and then you create triangulation in the plane. We then set the anchor points in order to generate this dome-like areas and also this interior courtyard. And then we apply all the things which we learned out of the models. So we use this kind of a zipper for the connections in order to fix the movement of the panels. And in order to fix the panels with each other, we use additional elements, which also helped us a lot, or actually helped the students a lot in building this structure, because they had this like handle-like shape. And it was interesting to see that, okay, we did the design work within 2 days, and we managed to get to a point where we said, okay, we're going to build this, but still mistakes happened in the design phase as well as in the construction phase. So we had like 3 missing components and 3 duplicate ones, and out of 1,000. And here the system once again. So we have like these handles which define the angle between the panels, and you have the pins which fix the entire system. 570 panels. And as I said, 50 millimeters plywood. We had 200 square meters, and we managed to use just 180 of it. And then the hard work was actually the construction phase. And it was nice to, first of all, see it built, I guess, for most of all for the participants. But what I found most intriguing and most interesting was the fact that it did not only carry itself, but it also allowed during deconstruction people sitting on top of it, which is not very intelligent in the first phase, but nothing happened. Yeah, thank you. Questions?
Well, through your work, you start out with the development of almost a formless structure. It's unique because you're working with components which have a very objecthood to them. They have a characteristic of their own. But yeah, when they're put together, you create almost in the Yves Klein sense of a formless structure, and then even going to the transparency one, we get to almost a complete formless. But as you've continued through your work, and even at the pavilion at the end, we're coming up with a form. I guess my question is, as you have kind of come out of the formless into this form, do you see this kind of progression into something that has more of a character as the same components in the beginning?
No, I think these are two completely different two completely different things. That's very true, but I think for the sake of exercising, because this was also kind of the, let's say, idea behind it, for the sake of exercising throughout a semester for short periods of time, this allowed the students to also, let's say, think about the process of generating, let's say, shapeless forms, basically, because you have like all these structures do not have a predefined shape. Of course, in this case, if you have a square, then it's going to be a square. It's not going to be something else. But yeah, to some extent, it's easier, I think, to work with not defined shapes, because it gives you a lot of opportunities and a lot of freedom. Whereas the last structure kind of confines you. But it was also not a structure which somehow got imposed. It was, let's say, a design process which we guided. So, yeah. I do not think that one is better than the other. If that, so, yeah. It's not it's definitely not a linear kind of research, and it's definitely not like we had chapters which we wanted to arrive at a certain point. It's, as I said, some sort of an emergent design in terms of the whole process is kind of emergent. So we started there, and then we looked into this, and it always comes to the point where we want to produce and to fabricate. So let's say this is the common point between all of them. So to have this sort of development from learning something, but by doing so, in order to be able to grasp it somehow, either at the scale of a model or at the scale of a one-to-one, let's say, human scale structure. We personally like to develop the things as we go, so that's why we of course show some things which maybe influence in some sort of way the outcome. That's possible, but we do not serve scripts and say, okay, design with this, because then it's basically like using just a normal software or whatever. So we like to let the people a little bit develop their own ideas and think about it. That's why we also work with models, because maybe you don't have the experience to develop the script in such a short period of time to express the ideas you have. So maybe you are better at working with models, and then we come, let's say, with this technical assistance to kind of implement the idea. So, yeah, it's kind of.
Yeah, but then again, for the last project, you had like a triangulation and kangaroo and everything in 2 days. It's like.
Yeah, it was kind of a sporty situation, but we had to do it. So we had a week, and at some point, of course, we had the difficulty of not having anything to build. So we just pushed the students to decide what they want to do and start designing, because you always get into, when you have groups, you have these situations when there are a lot of discussions about nothing actually. Yeah, so then you just tell them, okay, you are either going to do it or we're not going to build anything, and then it's happening somehow. So sometimes, because in China I didn't. So, but it's also a different situation, because in China, yeah, it just was completely different. So yeah. Well, I think the topic we chose, or the material we chose, which is similar to the one we used here, let's say, is easy to work with when you don't have a structure. So you work with components and then you implement whatever. You build 100 components and then you somehow stick them together. But what we wanted to achieve there was also to generate a structure with the use of the components. So it was a little bit too far-fetched from our side in that case. Yeah, but the outcomes of the workshop were very interesting anyway for us, and I guess for the students as well. Okay, thank you very much.